All right, I'm going to begin section 7.2 here now. 7.2 is called trigonometric integrals. And I've got some identities that you're going to want to know here on this page. So the Pythagorean identities, I would definitely have those three memorized. You'll need those a lot throughout the course. The sum and difference formulas, you may need once or twice for a problem. They're not really, ones that you definitely need to know. But the double angle formulas, I would know sine of 2x and cosine of 2x. The power formulas, you'll see those a lot for sine squared x and cosine squared x when we get into chapter 10. Okay, they'll be used a lot there. And then also in this section, there's the product to sum formulas. Okay, we'll need to know those at the end of this section. So let's see. In section 7.2, like I said, we're going to talk about trigonometric integrals. Here's some identities to know that are on that sheet there. So let's take a look at some examples. Okay. Suppose that we want to integrate cosine squared x times sine of 2x. Okay, well, it would be nice if I had all single angles or all double angles. Okay, here I've got there's a single angle function and there's a double angle function. So sine of 2x, that's the same thing as 2 sine x times cosine x, right? So where I see the sine 2x, I'm going to go ahead and use that double angle formula, and I'll replace it with 2 sine x cosine x. Cosine squared x times cosine x, that's cosine cubed x. The 2, that's a constant that can come outside the integral. And then I got sine x dx at the end of the integral. Okay, that allows me to make a u substitution here. So if I let u be cosine of x, du is negative sine x dx. So a negative would have to come outside of my new integral involving u. And I'd have negative 2 times the integral for u cubed du. Okay? And the antiderivative then would be negative 2 times u to the 4th over 4, or negative 1/2, u to the 4th, plus a constant. So u is cosine x, right? So my answer is going to be negative 1/2 cosine to the 4th of x plus c. Okay, and just like all these other integration problems, like I'll know if I have the right answer if I take a derivative and I can get my integrand. Okay, and now for these problems, like if I take a derivative, like I might need an identity just to get this double angle formula again. But anyway, the point is that you will always know if you got the right answer. Okay. Another example we can try is, so what if we want to integrate cosine cubed x dx? Okay, well, so I can't just add 1 to the power divided by the new power, right? Because when I take a derivative, the derivative of cosine x is sine x, and I don't see a sine x term anywhere inside that integral. So cosine cubed x, so let's go ahead and break away a cosine x term. And cosine squared x times cosine x dx is left on the inside there. Now, the identity, sine squared x plus cosine squared x equals 1, means that cosine squared x is 1 minus sine squared x. Okay, so where I see the cosine squared x term, let me go ahead and replace that with the 1 minus sine squared x term, and then I still got the cosine x dx part at the end. Why I did that is because that allows me to then make a u substitution. So, and by the way, a lot of these problems are going to involve, use substitutions somewhere along the lines. So keep that in mind. But so if I let u be sine x here, du is cosine x dx. So I'll be able to knock out that part at the end there. And I have the integral for 1 minus u squared du. Okay, and so the antiderivative of that then would be u minus 1/3 u cubed plus a constant. There's an indefinite integral, so remember to tack on the plus c there. And my original integral was involving x, right? So I want my answer to involve x. Well, u is sine x. So where I see u, let me go ahead and replace that with sine x. I got sine x minus 1/3 sine cubed x plus c. That's going to be the answer there. Okay. Now, and the next problem here, we're integrating sine to the 5th x times cosine squared x dx. Okay, well, I know that cosine squared x, that's the same as 1 minus sine squared x. And so, if I were to use that identity and then distribute the sine to the 5th x, I'd have sine to the 5th x minus sine to the 7th x. I don't know what that is, what that antiderivative is. Okay, so that identity there is not going to help me yet in this problem. Okay, but what I could do is, so the sine to the 5th of x, let me go ahead and break away one sine x term. So I got sine x times sine to the 4th of x, that's sine to the 5th of x. And then let me use this identity. Okay, so sine squared x, that's the same as 1 minus cosine squared x. Right, so I got 1 minus cosine squared x squared, because it's really sine squared x squared is sine to the 4th of x. And then times, I still have this cosine squared x times sine x part left inside the integral. I'll just leave that as is there. And why I did that is because that allows me to then use the u substitution. Okay, if I let u be cosine of x, du is negative sine x dx, and I've got that inside the integral, so I'll be able to knock out that part there. And the new integral then involving u is, so this negative can come outside the integral. I got negative the integral for 1 minus u squared squared times u squared du. Okay, and then the next thing that I'm doing here is if I FOIL out 1 minus u squared squared, that's 1 minus 2u squared plus u to the 4th. And then I'm distributing the u squared into those three terms. Okay, so I'm at this part here, and now I can get the antiderivative. So I got to, let me also bring in the negative there into these three terms. So I'm going to have negative 1/3 u cubed plus 2 u to the 5th over 5, and then minus u to the 7th over 7, plus a constant. There's an indefinite integral. And so the last thing then would be to replace u with cosine x. Okay, so my answer then is going to be negative 1/3 cosine cubed x plus 2/5 cosine to the 5th x minus 1/7 cosine to the 7th of x plus a constant. Okay. Now, how about let's do these next two examples here. So in this next example, it's I got cosine squared x. I'd like to know the antiderivative of that. Well, cosine squared x, that's the same as 1 minus sine squared x, right? But that's not going to help me at all, because then I'd have to know the antiderivative of sine squared of x. Okay, so, and if I were to use that identity again, it's like I would have just made a big circle and gotten nowhere. Well, so we're going to need an identity here. Let's use the identity for the power formulas, the one for cosine squared of x. So that's the same as 1 plus cosine of 2x divided by 2. Okay, I'm using that guy right there. And so, yeah, and 1/2, that's a constant that can come out of the integral. So I'm integrating 1 plus cosine of 2x. Well, now I can go to the answer. So I get 1/2 times the antiderivative of 1 plus cosine 2x, that'd be x, plus, let's see, the antiderivative of cosine of 2x, that'd be, well, sine x, the derivative of sine x is cosine x. I get a cosine 2x though. So it'd be, sine 2x. But then if I take the derivative of sine 2x using the chain rule, I have 2 times 2 times cosine of 2x. I don't have a 2 in front of there. So to offset that 2 that would be in front of the cosine of 2x part when I use the chain rule, I'm going to need a 1/2 in front. The 1/2 times 2 is 1. Okay? So, yeah, the antiderivative then of cosine of 2x would be 1/2 times sine of 2x. You could also use a u substitution on that. Let u be 2x. Plus a constant. Okay? So then the last thing I did here was distribute the 1/2 into these two terms. So I got 1/2 x plus 1/4 sine of 2x plus c. Okay. This next example is a definite integral. So now I'm integrating cosine to the 4th of x on the interval 0 to pi over 2. Okay. Well, let's see. So that's an even power, right? With that being a power of 4. So this problem is going to be kind of like the last problem there, where I'm going to need to use this identity. Cosine squared of x, that's 1/2 plus 1/2 cosine of 2x. Okay, I'm squaring that result because it's cosine to the 4th of x. And here's where I'm at so far. 1/2 squared, that's 1/4. 1/4 is a constant. I can bring that out of the integral. And 1 plus cosine of 2x squared then would be 1 plus 2 cosine 2x plus cosine squared 2x when I FOIL that out. Okay, now I know the antiderivative of 1 and the antiderivative of 2 cosine 2x. I don't know the antiderivative of cosine squared 2x, but I can use the power formula there. So now the one that I have for you here is for cosine squared of x. I don't have a cosine squared of x. I get a cosine squared of 2x. So I guess where I see the x part in this formula, here I'm going to want to make that be 2x. So cosine squared of 2x, that's 1/2 plus 1/2 cosine of 2 times 2x, or cosine of 4x. All right? 1 plus 1/2, that's 3/2. And now this allows me to then find the antiderivative. So it's going to be 1/4, keep that in front there, times 1 plus 1/2, that's 3/2 times x, plus the antiderivative of 2 cosine 2x, that's sine 2x. So again, when I take the derivative of sine 2x, that's using the chain rule, it'd be cosine of 2x, then times 2, it's right there, okay, plus the antiderivative of 1/2 cosine 4x, well, that's going to be 1/8 sine of 4x. okay? Because you're going to have sine of 4x divided by 4 times 1/2. Going to give you the 1/8 there in front. So then the next thing that I do is plug in the bounds. I plug in the upper bound first, lower bound second. So when I plug in pi over 2, I get 1/4 times 3 pi over 4 plus sine of pi, that's 0, plus sine of 4 times pi over 2, that's sine of 2 pi, that's 0. And then when I plug in 0, all three of these terms are going to be 0. Okay, so I end up getting 1/4 times 3 pi over 4, that's 3 pi over 16. Again, always give the answers in exact form for me. Okay, that's how the book will have it too. On this next page here, I have just kind of the guidelines for evaluating integrals involving sines and cosines. So if you have an integral of sine to the power m of x times cosine to the power of n of x, if m is odd, you're going to save a sine x term, kind of like what we did in this problem here. We saved a sine x term, and then we convert the remaining factors to cosines. Okay, then you're going to use substitution. You're going to let u be cosine of x. If n is odd, you're going to save one cosine x term and convert the rest of the factors to sine x. That way, when you make a u substitution, let u be sine x, then you're going to have a du be cosine of x. Okay. If m and n are both odd, you can use either 1 or 2. It's not going to matter which one. If m and n are both even, then you're going to use the power formulas. Okay, these formulas right here. So yeah, that's kind of just the guidelines for evaluating integrals involving sines and cosines. Okay, I guess the next thing we'll look at some integrals involving tangents and secants in the next video.